Terms are over, and for the rest of the semester what we're going to do is start working in 3 dimensions. I would like to mention that before we get started, those that are kind of leaning on the external videos for class, we are seeing some missing homework, and I just want you to know that you really need to stay on top of that. Procrastination doesn't work very well in this class, and you're going to get behind and then you're going to get discouraged. So I would say if you're using the outside videos, depending on those, make sure you stay up to date with them. It doesn't take long to get into trouble. Hopefully in the next week I'll have some grades. If those that may be in trouble grade-wise, I'll be sending you out a spreadsheet of your particular grade so you can see where you're at right now, and then we can go from there. But try to stay up on this. 3D. We're going to start incorporating that Z dimension, which takes a little bit of practice. I think we're pretty versed in, I was going to say well versed, but I'll say versed in the 2D aspects of it. A lot of the two-dimensional tools that we've been using we will continue to use in three-dimensional modeling. And to get started, let's go ahead and open up our seed letter mechanical 1 seed file. And we know we're working in inches and all that other good stuff. So once you have this up, just do a File, Save As. And we're going to put this in our Projects directory. And we're going to call it Project 8 3D with your initials. Oops. 3D CJ. Hit Save. So now we're currently working in this three-dimensional model, but we're still in a 2D file. So how do we get away from that? We could start out with a three-dimensional seed file, but one of the easier ways to do this is just go to your model tool. What we're going to do is create a new model. Click the Create New Model tool. This time it's going to be a design file, and we're going to say 3D, and we're going to call it 3D model primitive, because that's the first thing we're going to learn is drawing primitives. And just say OK. What you'll notice now is that all of a sudden at the top, it's rather than 2D, it says we're in a 3D model, and nothing seems to have changed. However, you can see that we're in a top orientation. If we look at this view rotation tool now, we can see we have top, front, right, and isometric. So we're going to work in this isometric view because it's easier. We could actually bring up the, and maybe it's better if we do that, we'll bring up 4 views, and then so down here at the bottom you'll see it says view 1 is open. Click view 2, 3, and 4. And do a window tile. Now you can see we have a top view. It just does this automatically when you open up new views. Front view, right side, and 3D. It looks like we've got a grid pattern on here, so we'll go to Settings, View Attributes, and turn off the grid. And in this case, I think we need to do it. We can do it. Apply to open views. There we go. Now we can turn it off. So this tool here applies to any view that's open. You'll also notice if I hit the space bar. Oops. There we go. Y coordinates there, but let's go check and see why that's... Bear with me. Settings, design file. Still working in inches to 2 decimal places. That's right. Ah, that's what it is. Isometric lock was turned on. Now let's see. No, wasn't. Not sure why. I should when I'm in distance angle with a z dimension here. I want it to be in XYZ coordinates, so I'm not really sure why that is showing up this way. Should be able to hit the space bar. Utilities, let's go to settings, Accudraw, display coordinates, rectangular. Now I had to change it here for some reason, my space bar, so now we're seeing X, Y, and Z coordinates, so I apologize for that. So how's this work? We'll kind of scrunch up the drawing tool, and you can see now we have solids modeling and surface modeling and feature modeling. These are all three-dimensional toolboxes that show up when we do a three-dimensional model. So let's start with the solids modeling. See, we have a lot of tools here, and E1 is actually our primitives toolbox. The first one we see is a slab solid. Let's click on that. Slab solid. We can set, just left click in this top view, we can set a width of say 1 and a depth of 0.5. You see what happens now? The cursor of the compass goes vertical, and I pull my mouse down into the front view, and then we can set the actual height of this object, and we'll say this is 1 also. If we do a fit view, just click the fit view tool once, and then just left click in each view. We can see the same object in each view, but in a different view. This is the top view, this is the front, this is the right side or the end view, and this is the isometric. We're just doing a default level. Let's do another one just for practice. We'll go 0.5, 0.5, just like you're drawing a two-dimensional rectangle, and just come down here and do 0.5 for the height. And now we have 2 of these. You can see by default, oops, I didn't really mean to move that there. There we go. Window tile just to fill up the boxes. These are what we call wireframes. If we actually drop this second toolbar down, we can say, let's look at it as an illustration with shadows. Just in the isometric view, we could actually do the same thing in any of these views, but it's probably easier to leave those as wireframes. So we actually see the physical object over here in the isometric as we're drawing these. And we can actually do a rotate view dynamically and actually be able to pull these things around into different angles that are not isometric. And when we want to get it back to isometric, we'll just say isometric view. So it's actually pretty simple. And a lot of times we can draw directly in the isometric view. And I want you to remember these 4 letters. They make the word soft. S, O, F, and T. And those letters stand for S for side, O is our origin tool that we use in 2D, same function, F is for front, and T is for top. And these have to do with our compass rotations. Let's take our Smart Line tool and just left click in this top view, and you see that our compass is laying flat. That's the T for top rotation. Watch what happens when I hit F. It rotates to the side. But you see down here in this front view, you can see my compass is exactly right. Up here it's not. If I hit S, it rotates it vertically, so I have to move over into this right side view to see that compass. The same thing happens in our primitive, and let's maximize the size of our isometric here and do another Smart Line. And I'll use a little thicker line weight. You can see that I'm in a side profile. If I hit T, it rotates my compass to a top. If I hit S, it rotates it to the side, and F rotates it to the front. Now let's imagine we want to draw another box. We're going to say, left click here, and we'll just say hit rotate top, T, and we'll say 1 by 1 by 1. Now after I set the first icon, or the first distance, 1, it automatically stays in the top and allows me to do the second distance. And then you'll notice that the compass automatically flips up. It's no longer a top view, it automatically flips to a side or a front view and allows me to create these boxes. So we can draw everything in the isometric view. If we go back to our other views and do a fit view, we'll see those other objects in space. It's a little more difficult to determine how we're placing these objects on the screen when we do this. But going back to the isometric view again, let's say we have this green box, and I want to place a box that is over 1 and 1 in this direction to start it, so we know which way we're going. If I just hit my middle mouse button, or left and right, or do the tentative button, however your mouse is set up, and hit O, you can see that I can move over a distance of 1. I'll hit O again, move in this direction, 0.25 for instance, and then hit a left click. I can start my box here at 0.25, and we'll just say 1 deep. So it's easy to move within the space if we have an existing object that is in the area that we know it is. We can offset from that to a specific location, just like we do in two-dimensional drawing. So let's look at some other objects and primitives. And the next one, I'm going to skip over this, well, we can do a pyramid solid. I don't use this one too much, but it's inscribed. We'll just give it a shot. I'm going to change my color to this purple color, and we'll do a pan up into this direction. You can see that we're setting, let's try rectangle. So we're going to draw a rectangle, and it says define the height. We define the height, and then we draw the width in this direction and the width in this direction. I just did that freehand, so I didn't actually put any. So again, start with a square in the bottom, pull up the height, and we pull the width and the depth. So we can create this pyramid, like this footing pier. Pretty easy to work with. Another primitive. Let's look at the next one. Is a sphere. A sphere is nothing more than drawing a circle that has depth. And we're using the center method, just like drawing a circle. Hit the center point, and it's in top view, and we'll just say we want a 0.25 radius, left click, and there's a sphere. Let's do a 0.5 radius. And let's imagine we want to put this sphere right on the center of this box. If I hit spacebar C for center, you'll notice it puts me right at the center point. I can come right out to this edge, and left click. That doesn't look right. Rotate it. You can see that that's why we're off on it. Let's try it a different circle, spacebar C. There. Come out to this edge. And now when I rotate this up to a top view, you can see that that sphere is directly on top of the box. And if I knew what the depth was, you can grab these just like you would a circle. So if I wanted to move this, I can grab it by the center point, hit F to move it straight up, or S to move it, well, straight up also. T allows me to move it horizontally, side to side. So if I knew it was the center, I need to move it out one, just move it out there. Again, we're using the same move, copy, fence tools, everything we used in 2D, we're using in 3D to manipulate these objects. The next tool we have is a cylinder. I want you to click on that cylinder. The cylinder is just like drawing a circle, top view, we'll say 0.5 per radius. And we just pull it up and say, what's the height of this cylinder? Let's say it's 0.5 also. That's how easy it is to draw a cylinder. Just like we drew the pyramid solid, we can draw a cone solid doing a radius on the bottom, pulling up the height with the mouse. You notice how the compass rotated automatically, and then putting in a radius or just leaving it pointed at the top. So it can either be capped or topped. You start combining these primitives together, you can start making some relatively complex models. Here we have another one, which is an elliptical cone solid. So we're just like drawing an ellipse. We have primary radius, secondary radius, pull up the height, and again we have primary radius and secondary radius. So those can be two different radiuses. A lot of times we'll use this same type of effect with sheet metal, for instance. Here we have an ellipsoid. And remember, if you're confused, you don't know really what to do, look down at the bottom. It says enter center point. So let's change our color to something else here. We'll enter a center point, and it says define a primary radius. Okay, we'll come out here. Define a secondary radius, so it's just like drawing a two-dimensional ellipse. Then it says define the tertiary radius. Well, just take your mouse and just kind of pull it up, same distance, and you've basically drawn an egg. So it's just drawing ellipses and following the instructions on the bottom of the screen. Again, primary radius from the center point, secondary radius, and let's do a really thick one so it's going to look like, and when you kind of rotate this around now, you'll see it looks kind of like a vertical flying saucer, so it's kind of cool. If it has different radius in the height portion, or the tertiary, whatever that is. Next we have, these are starting to get fun, so we'll go to a torus, donut, inner tube, whatever you want to call it. This one's a little more difficult. It says enter a start point. So I enter start point out here. And it says define a center point. Well, we'll define a center point back here. And then it says define angle and secondary radius. So this takes a little bit of mouse work. So you can take this, you pull it straight out, and then put in a secondary axis, which might be, say, 0.6. And there's our inner tube. Kind of cool. Or a torus, if you want to be specific about it. Let's do another one right here. Start point, come back to the center point of your torus, and let's go back a distance of 0.8, left click, and just pull it back in the same direction again. See how I pull that right on the smart line? See how I get that smart line? And if that was 0.8, I'll say I want this to be 1, the distance back, right there. So there's 1, which is 0.8 plus 1 would be the radius and the direction of that second point. We can place that right in there. Two more. We get the wedge. A wedge solid is nothing more than a center point, and it says define the radius. So we'll come out here and say the radius is 0.3, and it says define the angle, and you can see how you can swing this angle in either direction. And let's just say the angle is going to be 45. That's about 45 right there. And you just pull up the height. Height will be 0.3. And you have a wedge. You don't use this that often. You could do the same thing by taking a cylinder and just cutting it. So we've got these objects here. Last one we have is a polyhedron. Number of faces we can adjust. Let's say we want an 8-sided or 12-sided polyhedron. I want to draw this in, let's do yellow. And I'll just start here. And you can see as you pull this out, just like drawing a center point on a radius, you can draw a polyhedron with any number of sides. Let's do a 20-sided polyhedron. Vertex. You can do them by vertex, edge, or face. Either 4, 6, 8, 12, or 20. So there we have all of our primitive solids that we can use to build things. And what I would recommend that you do is concentrate on this toolbox to draw all of the primitives in here. Get proficient at drawing these primitives. Just have fun with it. And again, you can take these primitives. If I want to take the center of this sphere and place it, spacebar C, on the center point of this box, you can just do it like that. If I want to take the same sphere here and place it on the center of this cylinder, it's automatically got a snap point there. Or you can place it out here on the center, hit the middle mouse button and hit O, and just pull it in, hit enter. Remember, enter works just like it does on any two-dimensional drawing. You can still lock the axis in whichever direction you're going and place your solids here. So these are great. We can go back and look at our, let's go to window tile, just do a fit view on these, take a look at what kind of mess we've made. You can see these are all over the place. You're never sure where you are when you're drawing them unless you're careful. So we're going to work on being careful. You can see as you move these around, I've just kind of spread them all out in different directions. But these do require key and accuracy, just like we used in 2D. You can make these conglomerate shapes and whatnot, and they work great. But really, we want to concentrate on being accurate and drawing these models to be able to create something that's realistic, that works for manufacturing, and in a few weeks you're going to learn how to export these to two-dimensional views that can be used just like we've done our 2D drawings. The difference being that we're going to be able to extract these two-dimensional views from these 3D models, so that we only do a 3D model and then we export the 2D views so that we can create 2D drawings from our 3D models. And that's the key to making 3D modeling something that is valuable. It used to be just kind of fun and neat to do 3D models. You can say, yeah, that's great, but you know, I need 2D drawings in order to give to my manufacturers and my subcontractors, and you were kind of stuck. You had to draw a model and then go back and do 2D drawings from something else. Now the computer software is set up to extract that information, put it in the sheet files. We still do our dimensioning the same way. And the other advantage is if we get done with this, we can make changes to that 3D model and create it in such a way that it automatically updates the two-dimensional drawings that are already there. So one-step changes can create automatic two-dimensional drawing changes that you don't have to do a thing on. And we'll work on that as we move along. Finally, just some fun stuff to kind of play around with is the ability to apply light. When we look at this information, if we're looking at this as smooth shadows, for instance, you can see it still got a background, but it's kind of dull looking. If we go to settings, rendering, light manager, we can simply double click on solar and turn on the sun and add solar light to our drawing. So when I render this now, it's added that solar light to the drawing. I don't know whether we saw any changes. Let's go back and say rendering, light manager. We'll see if we can turn it off. Double click off. Yeah, you don't see much there, but it does make a difference when we're turn down the ambient light. And what's the difference here? Ambient light is the light that kind of encompasses everything. Flashbulb light is when we're using artificial light. We don't have any artificial light, so you won't see any difference. And then the solar light is light that comes from the sun. And when we do this, you can see on the solar light, we can change the time of day. We can change the date. We can say date, give us today. You can see every time I change the time, watch when I slide this back and forth on the time, you can see the light changes on my model. We can orient it so we know which way north is. And we can also set the latitude and longitude. So if I select the position by city, and let's say I go here and say this project's going to be in Boston, and say OK, you'll see the light change. So it says on 11/25, I got the wrong date in here, must be my computer, October 25th, and at, let's say, 11:30 in the morning, that's where my light's going to be. If I pull up my ambient light and kind of spread that out a little bit, you can see how it kind of will darken things and lighten them. So the light is looking at this from different directions. If we pull it up further into the afternoon, say 1:30, and go back to our ambient light and kind of pull that down a little bit, we can see that our solar light is much more applicable. But when we look on the dark side, we see where our shadows are. So as we place these things on our models, we want to make them look the best in the best light. So we can adjust the light and make it appear on these in such a way that it gives it a better feel. It's going to show it in the best time of day, the best time of year. The shadows are going to be out there. We not only talk about, and this is, you know, some people say, well, why are you talking about light, and this is all complicated crap, and, you know, why is this important? Once you learn primitives, I think to get somewhat excited about what we're doing here, it's important to start playing around with light, and also to start thinking about material applications. We've got a bunch of different colors here now. Let's say, for instance, I want to make this red box look like pine. We can go to Settings, Rendering, Materials, and we can go to our palette under our material editor and just say Open. Hopefully I got some palettes here. You'll see wood. Grab the wood palette, and you can see, I'll see what we got here. These are all, there's a wood with smooth, so we'll just apply this to this object here, and you can attach material using this tool, and we'll talk about a little bit more, but attach material to this block, and as you pull this around now, we look at it from a different angle, and maybe that's the best one. You can see that now it has a wood finish on the outside, kind of a laminate. We'll talk about being able to do this. You can see I'm kind of running low on disk space, so I'm going to give it up. So play around with material applications and learning those things, and we'll do more and more, but just learn how to build these primitives, because we're going to extract everything off the primitives from this point on. So let's give it a shot and see how we make out. Thanks.